Before we start on the next section, I just want to talk a little bit about fractions. Okay, so the easiest thing to do with fractions is actually to multiply. If I have 3/4 times 8/9, how do I multiply fractions? Oh, you want me to cross cancel, right? Yes. So the way this would work is you could multiply across. You get 24 over 36, but you realize that that is not reduced. You always, always, always want to reduce. You can reduce it, or what you can do is you can think about the factors for a minute. The reason why I'm going to do this in a factored way as opposed to just cross cancel, because most people know, like, okay, 4 goes into 8 how many times? Twice. And then 3 goes into 9 how many times? 3. Which means that this would reduce down to 2/3, okay? But let's think about it in terms of its factors. 8 is the same thing as 4 times 2, right? And 9 is the same thing as 3 times 3. So when we're cross-canceling, we're finding these ones. 3 divided by 3 is 1. 4 divided by 4 is 1. So that's what we're actually cross-canceling. And you see what's left is the 2/3. Now, what if you were going to divide fractions? Let's say you had 3/4 divided by 3/8. How do you divide fractions? Yes. So you multiply, what we call that is multiplying by the, oh, I thought it was called the reciprocal. Ah ha ha. It's 3/4, so 3/4 stays the same. We're going to multiply by 8/3, and then we see here 3 and 3, that cancels. Those are both ones. 4 goes into 8 2 times, and then we multiply across. 2 over 1 is the same thing as 2. Okay, so all of that applies with these rational expressions. Yes. Okay. All right. So here, if we're multiplying rational expressions, we're going to multiply the numerators. P times R is PR, and Q times S is QS. And notice that the denominator, neither Q or S can equal 0. And then here, when we're dividing, we have PQ times the reciprocal, or we said the reciprocal, and that was going to be, what would be the reciprocal of RS? SR. And so we're going to multiply now all three of these, the R, the S, and the Q, none of those could equal 0. Otherwise, you'd be dividing by 0. P could be 0, but then it wouldn't be very interesting because we're going to get into all of that when we graph, yes. But P could be technically 0 because you wouldn't be dividing by 0. You see, you just can't divide by 0. Well, because we're going to be taking the reciprocal. Here, you can't have 0 in the denominator, and then when we take the reciprocal, it becomes to the numerator, but it started out in the denominator. Okay, so for here, we're going to divide, or we're multiplying a monomial times another monomial. So what we want to do is we want to look for these opportunities to cross-cancel, right? Or we could multiply across and reduce, just like we saw before. So is there anything that right away you want to cross-cancel? 7 and the 49. 7 goes into 7 once. 7 goes into 49 7 times. You're saying also the y. How many times does y to the first go into y to the 9th? It leaves y to the 8th, right? Because if you were thinking about it like this, y to the 9th divided by 1y, y to the first, what do we do to those exponents? Yes, we subtract y to the 8th. That's where we got the y to the 8th from. Now, what about here? -2 and 4. Does that cross cancel? -2 and 4. This becomes a -1 and 2. And then what about your x to the 3rd divided by x to the 7th? What would that leave you with? And is that in the numerator or in the denominator? we have more x's in the denominator. So if you want a positive exponent, you can leave 3 of these will cancel with 3 of these, leaving 4 left. And so that cancels. Here we have x to the 4th. And now this gets a little bit messy, so just make sure you keep track of everything. -1 times 7 times y to the 8th is -7y to the 8th over what? 2x to the 4th. Can anything else there simplify? No. Okay, now let's try it where we have some binomials involved. So the first thing we're going to want to do is we're going to want to factor. Is there anything that can factor? And by the way, there's an implied parentheses here, because if you were going to multiply this, you would have to distribute, but that's going to actually make it messier. So I would go y minus 8 times 12y to the 2nd over 4y. And then how does this factor? Y squared minus 64. Do you see what that is? Because we call that a difference of two squares. Difference of two squares. And then can anything cancel? What can cancel? Y minus 8 because they're exactly the same and they're in binomials, right? And they're in parentheses, so they're multiplied. Then what about the 4 into 12? 4 goes into 12 3 times. How many times does y go into y squared? Yes, 1 time, y to the 1st. So now we have, what's left in the numerator? And what's left in the denominator? Now that question might come up again. Can I reduce the y's? No, because this one is being added and this one's being multiplied. Okay, if that y was able to factor out and multiply, then we could reduce it. Okay, let's look at the next one. This is the division. And so when we divide, we're always going to, yes, which one am I flipping? I have m to the 5th over 8. I'm going to multiply by 12m over negative m squared. Let's think about what we can reduce now. Can I reduce the 8 and 12? Yes. What goes into 8 and 12 evenly? 4. 4 goes in here twice. 4 goes in here 3 times. It might be easier for me to round up all the m's. So why don't I do this? M to the 5th times m. How many m's is that? Yeah, so I have 3m to the 6th in the numerator. I have negative 2m squared. Look at that and tell me, can it reduce any further? What can it reduce down to? 4th, right? We're subtracting those exponents over 2. Now let me talk about the placement of this negative sign. How many people think the negative sign looks awkward in the denominator? Okay, I would either move it to the numerator or out in front. Remember that a positive divided by a negative is a negative. So this whole entire fraction is negative. So, you might see it as negative 3 halves m to the 4th. That would also be correct. Negative 3 halves m to the 4th, or the m to the 4th, even if it's on the side or in the numerator, it still is a positive exponent, so it still belongs up top. Okay, what about this one? What am I going to do to simplify here? Can I just start canceling x squareds? No, I always am going to have to factor, so that's our number 1 rule is factor first. And then why don't we factor as we multiply by the reciprocal? So what are the factors then here? X times x gives us x squared. What gives me negative 10 and adds to negative 3? Negative 5, positive 2. Okay, that stays. I'm going to not use multiplication as an x there because that will be confusing. X plus 1. I'm going to put parentheses around that to show that that's already factored. Now I want to multiply by the reciprocal. So why don't I use a dot instead of a multiplication so it doesn't look like an x? X minus 5 goes to the denominator, and who can tell me what are the factors of this one? Multiplies to negative 5, adds to negative 4. X plus 1, x minus 5. Does everybody see how she got that? And I'll put parentheses around that. Now, what can cancel? The x minus 5's good, cancel. And what else? The x plus 1. Yes, but there's I can't cancel them both. That would be kind of like the same, a similar example would be 25 divided by 5, right? Only one of them cancel. Yes. Okay, so what do you get here then? Okay, and then since we canceled things that were in the denominator, we could say still x cannot equal negative 1 and it can't equal 5. Do you see where I'm getting that, where x cannot equal negative 1 and it can't equal 5? There is, you know what's coming up in the graph. There would be a hole in the graph if we were to graph that. But it's just a good idea to say what it can't equal even though you canceled them out. And I didn't actually do that for all of these. Here I would say that x cannot equal, if we go back to this one, what would x not be able to equal that we canceled out? Yeah, actually I think it would be positive 8, right? And here it can't equal negative 8, but also what it canceled, one of the y's canceled. So what number would give you 0 for y? It would actually be 0, right? Because if I plug in a 0 here, I would wipe out the whole denominator. Okay, so let's go ahead and try this for looking at function notation. Actually, I'm going to pause. I'm going to stop this and do a new one.